Okay, so one more rate law for us to talk about in the integrated sense, which are second order reactions. Um, so if you consider an example of maybe two molecules of this methyl CH3, and they come together to make C2H6. Um, if you're told that this reaction is concerted or elementary, remind me, what does it mean for a reaction to be elementary? And so that's when we can take a shortcut and we can write the rate law from the reaction. We can only do that if it's elementary. So in this case, let's use the specific reactants instead of the generic A. I'm going to include these reactants in the rate law. And another way to write this would just be to have two molecules of CH3, right? So if it's elementary, we need to include CH3, that's the reactant, instead of the generic A. And the exponent here would be 2. It's second order because there are two copies coming together to make the product. And we know they have to both be in the rate law because they're reacting through a single step. I'll show that with an energy diagram.